So here I've got a simple equation for a linear regression model, and I'm computing the loss using the mean squared error. And the result of this is going to be a tensor. So I'm going to run that, put in the loss here so you can see it, and there's the loss. It's a tensor. The most important feature of torch tensors is that they keep track of what mathematical operations they were created from, and this is stored as the tensor's grad function attribute. And that's what you can see down there actually in the loss. Under the hood, PyTorch knows the mathematical function and the corresponding function of the gradient. And that gradient tells you how one value will change as the values it was created from change. And the reason why this is important for machine learning is that we need to know how the loss will change as the parameters of our model change, so that we can change them to get the lowest loss. And when we differentiate our loss, we want to know by how much changing each parameter is going to affect it. The grad function is the function that gets called to give you that number. And when the grad function is called, it stores the gradient of a tensor in its .grad attribute. But right now, if we take a look, the grad is going to be empty because we haven't differentiated anything yet. So actually it doesn't, yeah, it says none, and it gives us this big error. It says its grad won't be populated, so on and so on. I'll explain that in a sec. So to get the gradient of something with respect to all the variables that lead to it, we can simply call dot backward on that variable. So I want to find out how does the loss change with everything that contributed to it. So I'll just do dot backward like that. Now what this does is it recursively looks at the variables which contributed to this value, which were all of these ones. It calls their grad functions on the values which it was created from, and it stores that value in each of their .grad attributes. But we don't require gradients for every variable, and we don't need to waste time or compute calculating all of them. So, for example, we can't change the values of the features, so we don't really care about by how much changing them will affect our loss. So by default, Torch only calculates the grads of tensors which have an attribute called requires grad being set equal to true. And by default, any initialized values will have requires grad equals false, which is why I've explicitly set requires grad equal true for the bias and the weights, because these are things that I do want to spend the time calculating the gradient of when I differentiate something like the loss. But if any value used to create some variable has requires grad equal true, then the variable created from it will also have requires grad equals true, which is why if we print the, I'll print it up here, if we print the loss dot requires grad, that's going to be true, because this loss was created from things which had requires grad equal to true. And tensors that were initialized randomly or just loaded in won't have a grad function, as they weren't created from any other tensors. So none of these are going to have a grad function, because I just kind of pulled them out of thin air in this case. I just initialized them randomly. So to recap, when I call dot backward on a variable, it looks at which tensors created it and through what operation, and it calls the corresponding grad function on those tensors. And then it stores the dot grad in the attribute of that variable. So if I do loss dot backward, for example, it's going to look at the variables which created loss, call the loss's grad function on those variables to get a value which is the gradient of the loss with respect to itself in this case, which would be 1. But then for each of those tensors which contribute to the loss, like the labels and the prediction were the most immediate ones in my example, it's going to do the same thing. So if their required grad equals attribute is true, that is, it's going to do the same thing. And this continues recursively until all the values that contribute to the variable you differentiated have a .grad attribute assigned, if they require one. And what this means is that we can calculate the gradient of any variable without having to explicitly write out the equation to do so each time. Our neural networks can easily have millions of parameters, so we definitely don't want to be writing out the functions to compute their gradients explicitly. And that is the main function of PyTorch, to act as a library for automatic differentiation. And we call the system that does the automatic differentiation AutoGrad. And you can use it for differentiation in any context, not just for machine learning. So now you know about AutoGrad, you're almost ready to start using it for AI.